Well, this video is going to be a little bit different. I want to introduce a couple of new formulas. The demonstration that these formulas or identities are true is kind of complex, and I outline it in the textbook, and you can read it in the textbook, but this will be a verbal explanation of what's in the textbook, which is sometimes helpful. So, in many classes, math instructors do just put a formula on the board and say, this is true, we're going to use it. I think sometimes in the interest of time, I do that as well, but we have the time to do this, so let's talk about it. This is vitally important to mathematics. This is the foundation of all mathematics, is to demonstrate that what you're doing is true, okay? And it's, to me, it's one of the wonderful things about mathematics is that you can demonstrate the truth of what it is that you're working on. All right, so we're going to start off with the distance formula. Some of you may be familiar with this, some of you may not. That's fine, however it goes. What we've got here is 2 points on a coordinate axes, x1, y1, and x2, y2. And we want to find the distance between them. So the way this works is that we create a right triangle around these points where that distance is the hypotenuse. Okay? Now, the side of this triangle here is this y value minus this y value. Okay, that'll give you that distance there. That's y2 minus y1. All right? Similar situation here. Here's x2, here's x1. This side is x2 minus x1. All right, so if we use the Pythagorean theorem, that says that this squared plus this squared equals d squared. So, x2 minus x1 all squared plus y2 minus y1 all squared equals d squared. And then if we square root both sides, our d will be the square root of x2 minus x1 plus y2 minus y1 all squared in both cases. Okay, so there's the distance formula. It comes from the Pythagorean theorem, and we're going to use that in the demonstration that I'm going to do over on the other board. So let's take a look at that situation over here. Okay. So again, these diagrams are in the textbook, and what we've got here on the left is we've got a unit circle for one thing, okay? So this is the unit circle where the radius is 1, okay? Any place you see a radius, that distance is 1. And that's why this is the point 1, 0 over here, is because this radius is equal to 1, okay? So what we've got here are 2 angles. We've got angle beta right here in the red. And remember when we talked about graphing, we showed how this point x and y has the coordinates cosine beta, sine beta. This purple angle alpha is bigger, okay? And the point right here is cosine alpha, sine alpha. And then this distance between those 2 points, we're going to use the distance formula that we just talked about to represent that distance. Okay? Now, before we get to that, let's take this whole diagram, take this angle right here, which is the difference between alpha and beta, right? If this is alpha and this is beta, then the piece right here is alpha minus beta. Now let's take that and rotate it down like this. That gives us this diagram right here. Okay? So now this side is down here, this side is over here somewhere, and this is our angle alpha minus beta. This point right here is, of course, the cosine of alpha minus beta and the sine of alpha minus beta. And I mentioned a minute ago, that point right there is the point 1, 0. Now, the key here is that this distance between those 2 points is the same distance as it is between these 2 points, because all we did was rotate this, right? So that distance is going to be the same as this distance. And that's what we'll see if I point the camera over at the next board, which is right here. Okay? So what we've done is essentially x2 minus x1 all squared plus y2 minus y1 all squared, and then take the square root for that first circle, okay? And then the second circle, here's x2 minus x1 all squared plus y2 minus y1 all squared, and they have to be equal to each other because it's the same distance. That's what we were just talking about with those two diagrams that are over there, okay? They're both equal to that distance d. All right, so now that we've got them set equal to each other, we're going to go through, and our ending point, what we're looking for here is a formula for the cosine of alpha minus beta, okay? So that's what we're going to generate out of this, is an identity for cosine of alpha minus beta, and then we're going to use that to generate two new identities, all right? Okay, so the first thing we're going to do here is square both sides, and that's going to take care of these square roots. All right. There we go. All right, so we squared both sides. Now we're just working with what was underneath those square roots. Now we've got to square these three expressions. This one right here is minus 0, so this is just going to end up being sine squared alpha minus beta. I'll put that in just a minute. First, let's work with this one. Cosine alpha minus beta minus 1 times cosine alpha minus beta minus 1. So that's going to be cosine squared alpha minus beta, and then minus 2 cosine alpha minus beta, and then plus 1. And then we're going to have this thing right here as well, which is going to be sine alpha minus beta, oops, goes there, all squared, and then that'll just be sine squared alpha minus beta. So let's put this all up here. So cosine squared alpha minus beta, 2 cosine alpha minus beta plus 1, and then plus sine squared alpha minus beta. Okay, so that takes care of the right-hand side. Left-hand side right here, we've got to square this out, square this out. Okay, so cosine alpha minus cosine beta times cosine alpha minus cosine beta. So cosine squared alpha, and then minus 2 cosine alpha cosine beta, and then plus cosine beta squared. And then when we square this out, we'll get something similar, except with the sines rather than the cosines. So, let me write this out. I write this out because I'm trying to remind people that you can't distribute an exponent across addition or subtraction. Okay, so sine squared alpha, and then here and here we get minus 2 sine alpha sine beta, and then plus sine squared beta. Okay, so let's see if I can squeeze all of that over onto the left-hand side. So, cosine squared alpha, 2 cosine alpha cosine beta, and then cosine squared beta. And sine squared alpha, 2 sine alpha sine beta, plus sine squared beta. All right. So, now we've done a little bit of expanding. Now we're going to do some simplifying. First off, you've got a sine squared alpha, and a positive sine squared alpha, and a positive cosine squared alpha. Sine squared plus cosine squared equals 1. So that's going to be 1. There we go. Then you've got a sine squared beta and a cosine squared beta. That's another 1. Okay? And then those other two pieces are just going to stay the way that they are. Minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. All right. Over on this side, We've got a sine squared alpha minus beta and a cosine squared alpha minus beta. That makes 1. We've got another one here, and then minus 2 cosine alpha minus beta. And see, that's where we're headed, is we're going to isolate this and get an expression for it. So, let's add these together. See, I don't think I'll need to write all of this out again. I'll just put 2's here and here. And then we're going to factor out a 2. So that'll be 1 minus cosine alpha cosine beta minus sine alpha sine beta equals 2 times 1 minus cosine of alpha minus beta. And then we'll divide on both sides by 2. Okay, and again, to save space, I'm just going to erase this like that. Okay, so there we go. We factored out the 2, divided through on both sides by 2, subtract 1 on both sides, and again, I'll just erase this away. All right, and then the last thing we're going to do is we're going to multiply on both sides by negative 1. So this will be cosine alpha cosine beta plus, because we have to distribute inside there, sine alpha sine beta, and that's going to equal cosine of alpha minus beta. Okay, so there's our formula, and we're going to use that to generate a couple of new identities. All right, so let's see here. Let me rewrite this up here. See if I can fit it. Cosine alpha cosine beta plus sine alpha sine beta. Okay. So now I can erase all of this, give us some new space. All right. So what we're going to do here is we want to generate an expression for cosine of 2 theta from a formula for the cosine of theta plus theta. Now notice that this is minus. So we're going to have a trick here. We're going to write this as theta minus negative theta. Okay, that works, right? Because that'll make a positive. So, using this formula right here, we're going to have cosine theta cosine negative theta plus sine theta times the sine of negative theta. Okay, now what do we do about these negative thetas here? Well, let's go back and remember what we talked about with the trigonometry of the unit circle, right? Remember this diagram where it tells you which of the trig functions are positive in which quadrants? All of them in the first, sine in the second, tangent in the third, cosine in the fourth. So here's the thing. If your angle theta is here, then negative theta is going to be down there in the fourth quadrant, right? Remember we talked about how negative angles rotate in the opposite direction as the positive angles, okay? So cosine of negative theta is going to be positive just like the cosine of theta, right? Because the cosine's positive in the fourth quadrant. So we can say cosine of theta is going to be the same as the cosine of negative theta. And even if this angle theta is someplace else, when you rotate in the opposite direction, it'll still have the opposite plus or minus sign. But the sine function is not like that, right? The sine is positive in the first quadrant, but it's negative in the fourth quadrant, okay? But the reference angles will be the same, so they'll have the same absolute value, but opposite plus or minus signs. So let's see here. Actually, what I want to write is the opposite of what I've got up here. We want to say cosine negative theta is the same as cosine theta, and then the sine of negative theta will have the opposite plus or minus sign as the sine of theta, but the same absolute value, okay? All right. So that's going to allow us to replace these negative thetas. Here we'll just get a cosine theta. Over here we'll get a negative sine theta. And so then when we multiply these, well, when we multiply these two together, we get cosine squared theta. When we multiply these two together, that'll make a negative sine squared theta. So there's our first formula. Cosine of 2 theta is cosine squared minus sine squared. Okay. I think I'll leave that there for right now. And now let's talk about the sine of 2 theta. So we're going to generate a formula for the sine of 2 theta, and we're going to use a few tricks to do that as well. Right? And this is in the textbook. Remember, if this is theta, let's see. This is, how do I want to do this? Well, that's called as, let me just do what I did in the textbook. Let's see what I did in the textbook. Okay, I called them A, B, and C. A, B, and C. And if this is theta, this angle in here is 90 minus theta. Okay? Because these angles are always complementary. Right? Because all three of them have to add up to 180. We know this is 90. That means these two have to add up to 90 as well. So if this is theta, this is 90 minus theta. Right? If this is 30, this is 60. If this is 50, this is 40. And so on. Okay, so what I want to talk about here is the sine of theta is A over C. Okay? Let's see here. The cosine of 90 minus theta is also A over C. So that says the sine of theta is the same as the cosine of 90 minus theta. Okay. All right. So, how are we going to use that? So, we're interested in the sine of 2 theta. So, let's see here. What do we want to do? We want to talk about the sine of theta plus theta. So, that's going to be equal to the cosine of 90 minus theta plus theta. Okay? So that's all I've done. I mean, I could have written it in terms of 2 theta to begin with. Right? We could say sine of 2 theta is the same as the cosine of 90 minus 2 theta. Okay? So this and this are just saying the same thing. It's just that here I've split that 2 theta into theta plus theta, for the purposes of arriving at the formula that we're interested in. Okay, and that's based on this scenario right here. Okay. All right, so if we're interested in the sine of theta plus theta, we can calculate the cosine of 90 minus theta plus theta. All right, how are we going to do that? Well, first, let's distribute this negative sign inside those parentheses. So that'll be the cosine of 90 minus theta minus theta. Okay. So, now, let's call this one angle, and let's call this the other angle, alpha and beta, right? If we call this one alpha and this one beta, we can use this formula right here. So that's going to say cosine 90 minus theta cosine theta, and then plus sine 90 minus theta sine theta. Okay, and then that thing that I just erased that says that the sine of theta is the same as the cosine of 90 minus theta and vice versa. I can replace this with sine theta. And then I can replace this with cosine theta. and this is the sine of 2 theta. Okay? And notice how we've got sine theta times cosine theta plus sine theta times cosine theta. This is 2 sine theta cosine theta. And that is our second formula. Okay, well, there's a lot going on here. Okay, so let me put those two formulas up on the board where we can see them. So, what are we working with here? Cosine of 2 theta is cosine squared theta minus sine squared theta. And let's see here. Sine of 2 theta is 2 sine theta cosine theta. All right. Got one more thing to talk about before we start doing problems. Okay, we're not doing too bad on time either. That's what I just wanted to take a look at. All right, now this cosine 2 theta formula sometimes appears in other forms. So why is that? Well, sine squared plus cosine squared equals 1. So we can write sine squared as 1 minus cosine squared, and we can write cosine squared as 1 minus sine squared, right? And we can trade sides here because we know that this is true, right? We don't have to worry about just working on one side for that one. So if we do that, then take that formula, cosine 2 theta is cosine squared minus sine squared. Replace that cosine squared with 1 minus sine squared. All right? And we get 1 minus 2 sine squared theta. So that's an alternate form of this cosine 2 theta identity. Let's see. And then the other thing we can do here is to replace that sine squared. Now we have to be careful with this because of that negative sign. So this will be cosine squared minus 1 minus cosine squared. Distribute this inside there. Minus 1 plus cosine squared. And so this will be 2 cosine squared theta minus 1. And there we go. So those are all the formulas that we're going to need for section 3.2. I know it took us kind of a long and winding road to get there, but as I said, that is really the foundation of mathematics. Okay? It's good to use the formulas, it's good to understand how to use the formulas and in what situations to use the formulas, but it's really important to know that your formulas are true. Okay? Alright, so let's take a look at some of the problems from section 3.2 in the textbook. And you've got a list of all your identities on page 118. Let's see here. My goodness. Let's see. Need to find the assignment. I think I left it in my office. I'm not going to turn this off. I'll be right back. Yeah, if I turn the video off, it starts a new video. There's no way to pause and restart it. Okay, as I've discovered. All right, so let's look at the problems. You've got all the identities on page 118, and we've got the problems on page 120. So let's take a look at some of these even-numbered problems. All right, problem 2. Secant of 2x. And then over here we have secant squared x. And on the bottom, 2 minus secant squared x. And you can't cancel these because of the 2 and the minus prevent you from doing any canceling. So let's see here. Well, for starters, I'm going to rewrite this as 1 over the cosine of 2x. So that's going to be 1 over cosine squared x minus sine squared x. So that's not really, groundbreaking substitutions or changes, but at least it gives me an idea for where I want to go with this side. Okay? Because the secant is the reciprocal of the cosine, and then I can use one of these formulas for cosine of 2x in there. All right, so let's see here. What do I want to do on this side? Well, I know that secant squared has an identity that goes with it, right? It's tangent squared plus 1 equals the secant squared. So let's see what happens if I replace both of these with tangent squared plus 1. And don't forget your parentheses down on the bottom because that minus sign is going to have to get distributed. So let's see, what do we get here? Tangent squared x plus 1 on top, 2 minus tangent squared x, and then minus 1. Let's see here. So that's going to be 1 minus, well, on the top we'll have tangent squared x plus 1, and on the bottom 1 minus tangent squared x. I don't see any canceling that's going to happen there. I suppose, so a couple things. Right here, I could rewrite this as sine squared over cosine squared in both the numerator and denominator, or I can just back up and write this in terms of sines and cosines, since that's what I did over here. Okay? So I think that's what I'm going to do, is I'm going to back up and I'm going to rewrite this thing in terms of sines and cosines. 1 over cosine squared, and then 2 minus 1 over cosine squared. Okay? So let's make a common denominator here. Cosine squared over cosine squared. Oh yeah, this is going to work. I'm very happy about this now. Okay. The numerator, 1 over cosine squared x. In the denominator, I'm going to have 2 cosine squared x minus 1 over cosine squared x. And that was what made me say, oh yeah, we're headed in the right direction, because 2 cosine squared x minus 1 is an identity for cosine 2x. Okay? So, what order we do this in is up to you. At some point, we're going to flip this over and multiply by the reciprocal. Take the top, multiply it by the reciprocal of the bottom. These cancel out. 1 over 2 cosine squared x minus 1. That's 1 over cosine of 2x. And so we can just back this up to that point, and there we go. 1 over cosine 2x, 1 over cosine 2x. So you can see I had a false start there. I got sucked in by the secant squared, tried to replace that. I probably could have ended up in the same place, like I said before, I erased it and started over. But I chose not to. Okay, so that's problem 2. Let's keep moving with these. All right, problem 4. Problem 4 is pretty straightforward. So we've got 2 cosine x on top and the sine of 2x on the bottom. And we want to show that this is the same as the cosecant. Cosecant, 1 over sine x. All right. Over here, replace that sine of 2x with 2 sine x cosine x. Cancel the 2's, cancel the cosine. Again, the reason why we can cancel here, see how there's no plus or minus in here, right? Everything's being multiplied. These are all factors. That's what allows us to do the canceling. All right? Okay, and that leaves you with 1 on the top, sine x on the bottom, and there we go. All done. Okay, so that's problem 4. Let's see, we'll do a couple more here before we wrap things up, and then I'll make a second video to finish this section up. All right. Problem 6. Let's see here. Sine x plus sine 2x over secant x plus 2 equals sine x cosine x. All right. Well, for starters, this sine of 2x is 2 sine x cosine x. Down on the bottom, I guess everything's in terms of sines and cosines except for this one, so it looks like I'm going to have to write that as 1 over cosine. Because I don't really have any other choices. I mean, there's no other identities that I can use in that denominator there. All right, so what are we going to do now? We're going to need to make a common denominator down here. So this gets multiplied by cosine over cosine. And let's see here. So the top is still sine x plus 2 sine x cosine x. On the bottom, we're going to have 1 plus 2 cosine x over cosine x. All right. So let's turn this is where we're headed still. Let's take this and multiply by the reciprocal of what's on the bottom. So we've got sine x plus 2 sine x cosine x, and then that's going to get multiplied by cosine x over 1 plus 2 cosine x. All right. The key here, and I've been thinking about this ever since I wrote it down up here, see the sine x here and the sine x here? We're going to factor those out. Factor out the sine of x, and that'll leave you with 1 plus 2 cosine x, which conveniently cancels out with the other 1 plus 2 cosine x, and we're left with sine x times cosine x. And there we go. Okay, that one was a little bit tricky. You had to recognize the factoring out of the sine function, and you had to generate a common denominator down here in the denominator, and then flip it over and multiply. Okay. All right, let's keep going here. Let's see what else we've got in store. Problem 8. Problem 8. Sine squared x minus 1 all squared equals sine to the 4th x plus cosine 2x. Okay? Let's see. This thing we're going to have to square out. So that'll give us that sine to the 4th x, and then minus 2 sine squared x plus 1. And over here, sine to the fourth x plus cosine 2x. And really, here's the identity right here. 1 minus 2 sine squared. Here's 1 minus 2 sine squared. They're in a different order, but the order doesn't matter so long as you keep the sign that's in front of it, right? We can write negative x plus 7, or we can write 7 minus x. It's the same thing. And that's what's going on here. And so we're done, right? Because this is just cosine 2x. There's our sine to the fourth x plus cosine of 2x. And that's where we were headed. All set. Okay. Well, let's look at problem 10. 1 plus cosine 2x over 1 minus cosine 2x. And this is supposed to be cotangent squared x. Okay. Well, there's a variety of ways to go about doing this problem. Okay? One of them is to think about wanting to get rid of that 1 right there. Okay? So if I wanted to do that, I would replace this with this expression right here, because then those 1's would cancel each other out, and I would just be left with 2 cosine squared theta. Now down on the bottom, it's a little bit trickier. If I want to get rid of this one, I'm going to want to use this expression right here, right? Because this minus sign has to get distributed into that parenthesis. So let me show you what I'm talking about. On the top, I'm going to say 1 plus, the other one. 1 plus 2 cosine squared x minus 1. Okay, so I just replace that with that. Alright, now on the bottom, I'm going to do the other one. 1 minus 2 sine squared x. Okay, because when this negative distributes in there, we're going to end up, well, up on top, pretty straightforward. Those cancel each other out. We get 2 cosine squared x. Here we get 1 minus 1 plus 2 sine squared x. There's 0. The 2's cancel out. And yeah, cosine squared over sine squared is equal to cotangent x. All right. I think we've just got one more to look at. And like I said, I'll save the rest of those problems for a second assignment. All right. Problem 12. Cosine 2x on top, sine squared x on the bottom, and this is supposed to be cosecant squared x minus 2. Okay. Well, this problem actually really lends itself to that strategy I talked about called splitting a fraction. Okay? Let's see here. Now, which one of these, we've got to replace this cosine 2x with one of these expressions. Okay? Now, you see how this 2 here doesn't have any sine or cosine with it. So I'm going to use this expression right here. Now, if you chose one of the other ones, I'll talk about that after I do this. I'll go back and see what happens if we use one of the other expressions, okay? So first off, let's replace that cosine 2x with 1 minus 2 sine squared x over sine squared x. Okay, now this is where we split the fraction. And we say 1 over sine squared x minus 2 sine squared x over sine squared x. So these cancel. And there's our minus 2. 1 over sine squared, that's the cosecant squared. Okay, so that was quick and easy, but you had to recognize which one of these 3 to substitute in for cosine 2x. So let's see what happens if we did it some other way. What if we used the first one, cosine squared minus sine squared? So then we would have cosine squared minus sine squared divided by sine squared. All right, so we'll split the fraction. Cosine squared over sine squared minus sine squared over sine squared. Well, this is cotangent squared minus 1. Not exactly what we wanted. We wanted the cosecant minus 2. Well, we know that the cosecant is 1 plus cotangent squared, right? So we can just replace this with this, and now you've got a positive 1 and a negative 2. So there's cotangent squared minus 1, cotangent squared minus 1. A little bit of extra work, but you can see we can get to the same place by taking different paths. Okay? All right, so like I said, I think we'll stop there for right now. We've got some new identities to work from, so that page 118 in your textbook, please use that when you're taking the quizzes. When we come in for the final, you'll have a formula page that has those on there. I'm not asking you to memorize them, but to familiarize yourself with them by using them, okay? All right, I think that's it for today. If you have any questions, please let me know. Thanks.